Okay, number 1. The student council at Jefferson High School sold a total of 220 brownies and cookies during its fundraiser. Each brownie sold for 75 cents and each cookie sold for 50 cents. The student council made $136.50. From the sales of brownies and cookies, which system of linear equations can be used to find B, the number of brownies sold, and C, the number of cookies sold? Alright, again, let's just go back through here. Let's highlight some key information. Okay, there's 220 brownies total. Okay, each brownie sold for 75 cents and each cookie sold for 50 cents. I'm sorry, there are 220 brownies and cookies. So we got 75 cents for each brownie, 50 cents for each cookie, and they made a total of $136.50 from the sale. And they tell us that B is going to stand for brownies and C is going to represent cookies. So as I look at my answer choices, they already have all of these equations set up. I just have to match what goes with what, and these are fairly simple problems. Okay, let's look at the first equation for each answer choice. It gives us the total of brownies plus cookies. Well, looking at for my information, I've got a total of 220 brownies and cookies, so B plus C should be 220, so I'm good there. See, this one right here doesn't work. B plus C should be equal to 220. That one doesn't work, that one doesn't work, so it's between D and A. Now let's look at the second equation. We have 50 cents per brownie plus 75 cents per cookie. Here we have 75 cents per brownie and 50 cents per cookie. So see how easy it is to match this up? We just have to match it up with information. Each brownie sold for 75 cents. So I should have 75 cents times B brownie. So A is not correct because it's not 50 cents per brownie. It tells us right here 75 cents for each brownie and 50 cents for each cookie. So when you have a problem like this on the TAKS test, please don't get it wrong. It's just simply matching up the correct information to the answer choices. Okay, number 32. The graph of a system of linear equations is shown below. Which of the following is the solution to the systems of linear equations? Before I answer this problem, this is going to be a fairly simple problem, as long as you understand a couple of things. When you have a system of equations, you can have two lines that intersect because each equation represents a line. And where those two lines intersect represent one solution. However, when you're dealing with lines, they may not always intersect. You may have lines that are parallel. And if the lines are parallel, they will never intersect, meaning there will be no solution. And one final case, you may have a line just like that, and you may have another line that simplifies in some way to basically become the same line. And if it's the same line, they share all points in common, so that is infinite solutions. So, recalling that information and going back to our problem, we're looking for the solution here. Now we can tell that these lines at some point are going to intersect. So if I take and hopefully draw a straight line with my tool here, and I just extend this line on out. See, when they set the problem up like this, it's going to be just as simple just to draw this line out as long as your line is straight, and you'll have a lot easier time doing it on your paper than I am here. See if we can get close. So if my lines are straight, that tells me my solution is right here at the point 10, 2. J. You will see this question being asked in different ways, and there are many different ways to solve it. This one was fairly simple. Connecting the lines together and finding the solution on the coordinate plane.